Hello. Today we're going to be looking at heat. First of all, let's say what heat is. If you were to put a piece of metal, for example, into the fire, we know that the piece of metal would get hot. But what's actually happening inside the piece of metal? Well, let's have a look at some molecules inside the metal. Maybe there's some molecules inside there, or there are molecules inside the metal, or they're atoms of metal perhaps, okay? And if we have a look at just one of these, right, there it is, there's the atom or the molecule. What actually happens is the molecule starts to vibrate. It starts to move from side to side, yes, or maybe even starts to move this way, like this, okay, right? And it's moving, to and fro, and it's this actual movement of the molecule or the atom which is the heat. Now this heat is called kinetic energy. The movement is kinetic energy. When the molecule is moving, it has energy. The more kinetic energy it has, the more it's moving around. The more it's moving around, that means the more heat it has. Now, how do you feel heat? Well, let's say you pick up this piece of metal. Then this metal, all the molecules are vibrating. And when the molecules touch your hand, they start to vibrate the molecules in your hand. And if it's very, very hot, they can actually start breaking the molecules away from your hand and actually burning your hand. Now, you might be surprised to know that all molecules are vibrating, because basically all molecules are above 0 degrees Kelvin. They are above absolute zero. So 0 degrees Kelvin is absolute zero, right? And as long as they are hotter than 0 degrees Kelvin, the molecules vibrate. The hotter something is, the more the molecules are vibrating. The heat is the actual vibration of the molecules. These molecules, they might be in a solid form, a liquid form, or a gas form. Okay, let's clear that away, and let's talk about heat transfer. What's happened here? Let's talk about heat transfer. Heat, oops, wrong one. Heat transfer. Oops, heat transfer. Now there are different ways in which heat can be transferred from one place to another. That heat can travel from, for example, from point A to point B. So, and we're going to have a look at some of these different ways that heat travels. First, let's look at conduction. Now, imagine that we have something solid, a piece of wood or a piece of metal or something like this. Okay, there it is. There's a piece of wood or a piece of metal or whatever it is. Okay, and inside it, of course, there are lots of atoms or molecules. Yes, and if we heat up, if we put heat in here, then the molecules will start to vibrate around here. And they will start to bump into each other. So this molecule will bang into this one, 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 this molecule bangs into this one, This molecule bangs into this one, this molecule bangs into this one, and you can see that the heat is being transferred along the solid, along the piece of metal. So if you heat it up at this end A here, it actually will go to, the heat will travel to end B. So that's called conduction. Okay, now let's look at convection. Convection. Okay, if we have some molecules in a liquid or a gas form, the molecules are more free. So let's say we have a glass of water. There's the water. And there are molecules, many molecules of water in the glass. Like this again. Now let's say we decide to heat this up. So let me draw a candle. There's my candle. Yes, and we decide to heat this up. Now, as you can remember, the molecules start to vibrate, and when they are vibrating, they start to knock into each other. So let's draw some. This molecule bangs into this one, this molecule bangs again into this one, this molecule bangs against the side, this molecule bangs into this one, this molecule bangs into this one, this molecule bangs into this one. And the more you heat it up, the more the molecules bang into each other. And because they're banging into each other, they try and get further apart. And when they get further apart from each other, if you were to look at a fixed volume, because they're trying to get further apart from each other, this volume, this fixed volume, actually becomes a little bit larger. So the volume actually becomes a little bit larger, and we know this happens because if you heat water, water expands. So now this water has expanded, and therefore it's less dense. Another way of saying it's less dense is saying it's lighter, right? And because this water is lighter, as we know, things which are light, they like to float to the top. So the light water floats to the top, and the heavier water, yes, as we know, wants to sink to the bottom, right? So this is called convection. So let me just repeat that. The molecules get hot, they start to vibrate a lot, they push against each other, and because they're pushing against each other, they try and get further away from each other because they're crashing into each other. Because they're getting further away from each other, the water expands, the water gets bigger, and when the water gets bigger, it hasn't got so much weight, and therefore it's lighter than the other water, so the light water rises and the cold heavy water sinks to the bottom. So therefore the heat has travelled from the bottom A, right, to be at the top. So as we know, heat always rises. Okay, another way in which heat can be transferred is radiation. Now, I don't want you to get mixed up with this word here, because there are two ways we use the word radiation. We can use it to talk about atomic decay, which is radiation, or else we can talk about heat transfer through radiation. And heat transfer through radiation, you've probably come across it quite a few times. If you, for example, have a cooker at home or an oven at home here, you bake cakes, etc. in your oven. Right? So when the oven is on and perhaps your mum is baking a cake, the oven starts to get hot, and if you're standing quite near to the oven, yes, you can actually feel the heat from the oven, right? And the heat actually is traveling as radio waves. Actually, it's actually traveling as electromagnetic radiation, yeah? And that's how the heat gets from the cooker A, yes, to you B. Right. Now the interesting thing about radiation is you don't need a medium for it to travel through. You don't need any air for it to travel through. You don't need any water for it to travel through. Now it can travel through air and water, right? But it can also travel through a vacuum. It can travel through a vacuum, yeah? And in fact, when we're talking about global warming, the radiation, it's very important to talk about radiation because this is how the Earth receives its heat from the sun. Yeah? So here's the sun, yes, there's the sun shining away there, and the Earth is many, many miles away, and there's the moon, right? And what happens is, there's a lot of space, isn't there? And between the space, in between the sun and the Earth, there's a lot of space, and the radiation travels as radiation or electromagnetic waves, to reach the Earth. Yeah? And that's a very special property of radiation. The other two types of heat transfer which we talked about, conduction and convection, they actually need a medium to travel through. They need, for example, air or water or metal. They actually need something to travel through. But radiation, it doesn't need that. And so that's the only way that the Earth, planet Earth, can receive heat from the sun, is through radiation. So during this course about global warming, we're going to be talking a lot about radiation.